Pluto is a remote and puzzling, more unassuming planet that was once a piece of our sun-energized framework's planetary assembling. Anyway, later, dumbfounding declarations by discernible astrophysicists Neil deGrasse Tyson and Michio Kaku have carried Pluto back into the spotlight with a surprising divulgence. They proposed that this cool world is on a potential impact course with Neptune. But how could it be that this could wind up working? Additionally, what may be the repercussions of such a giant event? Are we seeing a captivating epic unpredictability, or is there another thing to this approaching huge battle? Join us as we dissect the expected results of a Pluto-Neptune collision. Pluto, a past planet that was renamed as a dwarf planet, is deficiently defined because of its staggering orbit. Its orbit remains a subject of interest and evaluation in the grandiose community, as shown by ongoing figures from leading experts. Pluto's orbit is perilously close to Neptune's, with both Neil deGrasse Tyson and Kaku sounding the alarm about a potential hazardous crash between these two planets that could represent a serious risk to Earth. How is such an event even conceivable? Pluto's orbit around the Sun is unlike any other planet in our solar system. It requires a stunning 248 years to complete a single orbit. Since its discovery in 1930, it hasn't fully completed one full revolution yet. But it doesn't stop there. Pluto's orbit is marked by its especially twisted shape, wandering fantastically far from the almost round orbits of the major planets. What makes Pluto's orbit even more stunning is its inclination of about 17 degrees to the ecliptic plane. How Pluto follows is much more skewed compared to other planets. This inclination and elongated nature add layers of complexity to its orbital plan. One of the most interesting parts of Pluto's orbit is its intersection with Neptune's orbit. For nearly 20 years in each orbit, Pluto actually draws closer to the Sun than Neptune, challenging what we could expect from their positions in the planetary system. This leads to the usual question: why hasn't Pluto slammed into Neptune? The answer lies in the gravitational effects of various planets. The assessment of Pluto's orbit began shortly after its discovery. Initially, astronomers tried to understand its curious path when compared to planets whose orbits lie generally near the ecliptic plane. Pluto's orbit stood apart with its steep inclination and elongated shape. The mystery grew with the confirmation that Pluto's orbit does indeed cross Neptune's. The stability of Pluto's orbit amid these intricacies is evidence of the complex nature of celestial mechanics. The three-body problem in space involves figuring out how three objects, like Pluto, Neptune, and the Sun, move and affect each other with their gravity. It's like trying to predict where they will go based on where they start and how they pull on one another. For Pluto's case, this problem shows how the orbits of Neptune and the Sun's gravity all interact in a complicated manner. The terms libration and resonance, along with the chi waving, are crucial for this problem, as shown by astrophysicists. What keeps all planets in their orbits is libration. In the particular context of Pluto and Neptune, this term suggests that whenever Pluto crosses Neptune's orbit, it is arranged something like 90 degrees away from Neptune. This spatial separation is crucial in preventing their orbits from affecting resonance. Resonance, on the other hand, refers to the periodic movement of a celestial body in its orbit. For Pluto, this means that when it comes closest to Neptune or any other giant planet, it is aligned completely above their orbital plane, providing an additional layer of safety from potential impacts. Another crucial aspect of this situation is the chi waving, named after three researchers, von Zippel, Capo, and Lev, who studied how objects move in space. It describes how three celestial objects, like Pluto, Neptune, and the Sun, pull on each other with their gravity. This pull affects how they move. For Pluto's case, the chi waving helps us understand why its orbit around the Sun is so unusual. Despite its seemingly erratic path, Pluto's orbit remains stable for what seems like billions of years. This suggests that Pluto's journey around the Sun has a certain order to it, even though it appears whimsical at first. Predicting major events, especially when they involve chaotic orbits like Pluto's, presents huge challenges. The inherent complexity of these systems means that long-term predictions are often fraught with uncertainties. While numerical simulations provide strong insights into understanding and forecasting the future paths of celestial bodies, they also highlight the limits of our predictive ability. These models heavily rely on the accuracy of initial conditions and the complexity of the interactions they simulate. Any minor error or deviation can lead to vastly different outcomes, making accurate predictions a daunting task. Furthermore, the turbulent nature of celestial orbits, like Pluto's, reminds us of the ever-evolving and dynamic nature of the universe. While we have made great strides in understanding space, the case of Pluto serves as a reminder that our knowledge of the universe still remains limited. Understanding the gravitational effects of the giant planets on Pluto's orbit gives critical insights into the broader dynamics of the solar system. It demonstrates how the presence and position of each planet can significantly affect the stability and behavior of other bodies within the system. So, why are prominent astrophysicists recently raising concerns about a potential impact between Pluto and Neptune? Despite these erratic forces working to prevent such an event, Neil deGrasse Tyson, a prominent astrophysicist and key advocate for advancing cosmology, offers an intriguing perspective on the mysteries of our nearby planetary system, especially the remarkable case of Pluto. Tyson, known for his role in the renaming of Pluto from a planet to a dwarf planet, provides insightful discourse on the evolving nature of celestial mechanics and the public's fascination with the strange corners of space. Tyson's stance on Pluto's renaming is grounded in the continually advancing knowledge of our local planetary system. He views the renaming not as a diminishment, but rather as a significant change in alignment with our growing understanding of the many bodies orbiting our Sun. Tyson's approach to celestial mechanics is one of continuous learning and adaptation. He sees the complexities of orbits like Pluto's as a sign of how much there is still to discover in space. The interest in these questions, particularly the potential interactions between Pluto and Neptune, highlights the dynamic and unpredictable nature of our nearby planetary system. His work emphasizes that the more we uncover about space, the more questions arise, pushing us to explore further and refine our understanding of the universe. Michio Kaku, another respected physicist and futurist, offers an alternative yet complementary perspective on the mysteries of space, focusing on the often violent forces that shape our universe. Kaku is known for his ability to connect complex scientific concepts with visionary ideas, making him a vital voice in discussions about celestial mechanics and the broader implications for humanity. Kaku's views on Pluto and its orbit highlight the need for ongoing observation and advanced modeling to predict and understand potential major events. He sees violent nature of space. Kaku's futurist perspective urges us to consider the broader consequences of such events, from their impact on how we understand the nearby planetary system to the possible need for future space interventions. His viewpoint underscores the importance of being prepared for the unforeseen in space. Kaku suggests that the more we understand the forces at play, the more prepared we will be to navigate and potentially mitigate the effects of significant events. Both Tyson and Kaku's views merge on the idea that space is an area of unlimited discovery and that our current understanding, while significant, is still limited. Their emphasis on the need for ongoing research and advanced modeling reflects the evolving nature of space science. They highlight the importance of not only understanding celestial mechanics as they are now, but also speculating on how they might change in the future. The potential impact scenario between Pluto and Neptune serves as a case study for the broader challenges and opportunities in space exploration. It underscores the need for rigorous scientific inquiry, cutting-edge technology, and a willingness to adapt our understanding as new information arises. For Tyson and Kaku, the mysteries of space, exemplified by Pluto's orbit, serve as a rejuvenating call for established researchers and humanity at large to continue pushing the boundaries of our knowledge. There is boundless scientific potential that, far into the future, the orbits of Pluto and Neptune will remain stable due to their mean motion resonance and the various gravitational forces acting on them. Therefore, a direct impact between Pluto and Neptune is incredibly unlikely. However, the complexities and potential disturbances in orbital elements still suggest that space scientists should continue to monitor and study these celestial bodies to better understand their long-term behavior and any potential risks they could present. While the possibility of a Pluto-Neptune impact is largely hypothetical and considered unlikely with current understanding, it highlights the importance of ongoing observation and monitoring in space science. Advances in technology and observation techniques will continue to play a crucial role in deepening our understanding of these fascinating phenomena. Advances in technology and observation techniques will continue to play a crucial role in deepening our understanding of these fascinating phenomena. As we expand our capabilities in space exploration, it becomes increasingly important to refine our models, improve our data collection methods, and enhance our predictive accuracy. The complexities of space dynamics, especially involving celestial bodies with irregular orbits like Pluto, require persistent observation and research. This vigilance will ensure that we are better prepared for any potential changes in these orbits and their interactions, whether they are gradual shifts or sudden, unpredictable events. The importance of this ongoing study is not only confined to understanding the dynamics between Pluto and Neptune. It also has far-reaching implications for our broader understanding of celestial mechanics. These insights could inform how we approach future space missions, especially as humanity looks to explore and possibly colonize other planets and moons. Understanding the behavior of distant bodies like Pluto will also help in assessing the risks posed by other celestial phenomena that could impact Earth, such as asteroid trajectories or even the potential for cosmic radiation shifts. Furthermore, the study of Pluto's orbit and its interaction with Neptune offers a valuable example of how the most seemingly distant and isolated elements of our solar system can still be deeply interconnected. While the possibility of a collision between Pluto and Neptune may seem far-fetched, it serves as a reminder of the unpredictable nature of the universe. The forces at play in space are not always immediately apparent, and what might seem like an isolated event could, in fact, be part of a much larger cosmic dance. As we continue to explore and study the solar system, it will be essential to keep an open mind and stay prepared for new discoveries. The future of space exploration holds immense potential, with questions still unanswered about the farthest reaches of our solar system and beyond. With scientists like Tyson and Kaku leading the way in promoting the understanding of space's complexities, we can look forward to a future of exciting discoveries, deeper insights into the forces shaping our universe, and a greater understanding of our place within it. In the end, the story of Pluto's orbit and its possible interaction with Neptune is just one example of the vast mysteries still waiting to be unraveled in the cosmos. Whether or not Pluto and Neptune collide, their relationship serves as a testament to the awe-inspiring complexity of the universe, reminding us that there is always more to learn and explore. As we push the boundaries of our knowledge, we must remember that space is not a static entity, but a dynamic, evolving force that challenges our understanding at every turn. The journey of discovery will continue, and with it, the chance to unlock the secrets of the universe in ways we have yet to imagine. As we continue to unlock the secrets of our solar system and beyond, the journey of exploration will be fueled by a combination of scientific curiosity, technological advancement, and international collaboration. The pursuit of knowledge about Pluto, Neptune, and the other distant bodies in our solar system is just one part of the larger effort to explore space. The possibility of new discoveries, from previously unknown moons to hidden interstellar phenomena, keeps scientists and astronomers alike motivated to push further. Moreover, the technological tools that support space exploration are evolving rapidly. Advances in telescopes, satellite technology, and space probes are allowing us to collect more data than ever before, with unprecedented precision. These tools, combined with improvements in computational models, allow scientists to simulate complex gravitational interactions and better predict the long-term behavior of celestial bodies. For example, NASA's New Horizons mission, which provided the most detailed images of Pluto to date, opened new doors for understanding the dwarf planet and its unique features, encouraging future missions to examine distant objects in the Kuiper Belt and beyond. The quest for understanding the origins of the solar system also drives much of this exploration. Pluto, once considered the ninth planet, provides valuable clues about the early days of our solar system and the processes that led to the formation of the planets and their moons. As a relic of the early solar system, Pluto holds the potential to help us understand not only the formation of our neighborhood in space, but also the conditions that might give rise to life elsewhere in the universe. This is why studying Pluto and similar distant bodies is crucial in the search for extraterrestrial life and understanding the